Today you're going to need this flap. This anchor chart is going to go on page 70 in your math notebook. So you're going to need this flap. It's got 6 times 2/3, and then it has a model and algorithm. This is going to be a little bit different because we're going to have 2 anchor charts for this concept. So this one you might want to glue in at the bottom of page 70. And then do the work for this on the flaps, as opposed to normally we do it on the paper, maybe do it on the flaps. So you're gonna need this for today's thing, and this is gonna go on page 70. Today we're gonna talk about multiplying a whole number by a fraction. So we're going to start talking about multiplying fractions. This is a lot simpler than multiplying or than adding and subtracting fractions. So this should be a lot easier because you don't have to change the denominator and all of that stuff. But you do have to really know your multiples and your factors in order to be successful in this. So we're going to talk about the 3 strategies that you can multiply a whole number by a fraction. And strategy 1 is going to be make groups. Or we're going to call this one repeated addition. So we're going to make groups, or we're going to call this one repeated addition. The problem that we're going to use for all 3 strategies is going to be 2/3 times 4. So if we think back to what we did with the M&Ms, we're going to have, this really means 2/3 of 4. So our multiplication symbol now represents of 4. And if we think back to what we talked about when we were scaling, is the answer to this going to be larger or smaller than our whole number? So we got to keep all of these different things that we've learned kind of in mind. So we want to, I guess we'll find out and see if it's larger or smaller, but you should have a decision made in your head to kind of help check us, to keep us on track. And when we think about our fraction, we remember that our denominator tells us how many groups there are. So 3 means, the denominator of 3 means that our 4 wholes are split into 3 pieces. So we have 2/3 of 4, but we're going to do repeated addition here. So we're going to add 2/3 plus 2/3 plus 2/3 plus 2/3. Well, when we add and subtract, we totally add the denominator. So we'll have 3, 6, 9, 12. Hopefully we said no. We keep our denominator the same, but we do add up our numerator. So we have 2 plus 2 plus 2 plus 2, which is 2, 4, 6, 8. So we have 8/3. Well, if we look at this problem, it's an improper fraction. We don't leave our answers in improper form unless we're being asked. So what we're going to do is we're going to convert this into a mixed number. And in order for us to do that, we're going to divide 8 by 3, because if we remember, this means division. Well, in order for us to divide, we need to find all the multiples of 3, or all the ones that we need. So we have 3, 6, 9, and we can stop at 9 because 9 is greater than 8, so we're not going to go in to that number that many times. So 3 can go into 8 how many times without going over? Twice, because 2 times 3 is 6. We're going to subtract. 8 minus 6 is 2. This is a good remainder. It becomes our numerator, and our 3 becomes our denominator. So 8/3 is equivalent to 2 and 2/3. So this is our answer. We have 2/3 of 4 equals 2 and 2/3, which is greater or less than 4. it's less than 4, because what we're doing is we're taking a part of our whole. So our second strategy is going to be strategy 2. Is going to be representing. And if you know anything about Miss Rostrom, she loves to represent things. That's why we practice adding and subtracting on grids. That's why we do all these different sort of things. So the second strategy is going to be representing. And how we're going to represent this, our problem is still going to be 2/3 times 4. This means 2/3 of 4, and our 3 represents our groups, how many parts our whole is split into. So how we're going to represent 2/3 is we are going to shade in 2/3 4 times. So we're going to have our wholes. We're going to model first on fraction bars, and then we'll model on fraction circles. Because I already know the answer, because we're using the same one, I know that it's going to be less than 3, so I'm only going to draw 3 holes. If I didn't know, maybe I'd want to draw 4, just in case. So how many parts am I going to split my whole into? Well, where do we look in our fraction problems? We always look at the denominator, because our denominator is king, and it says 3. So that means that each one of our wholes needs to be split into 3 pieces. Then I'm going to shade in 2/3 how many times? Because I'm multiplying by 4. So on this first one, I'm going to do slashes. Shaded in 2 because that's what my numerator says. So there's my 2/3. There's 1. Then do squigglies in this one. There's 2. So there's 2/3, 2/3. Then putting spirals in this one. There's 2, so 2/3, 2/3, 2/3. That's 3 2/3. No more gonna go. So we have 2/3, 2/3, 2/3, 2/3. We have 1, 2, 3, 4. We shaded in 2/3 4 times. Well, how many holes do we have? We have 1 hole, 2 holes, and how many parts? 2/3. So our answer is going to be 2 and 2/3. Now we're going to do the same thing but on fraction circles, just so we can kind of see how we model on both of them. Well, how many parts are we going to split our whole into? Hopefully everybody's saying 3 because that's our denominator. So we're going to split our wholes into 3 parts, 3 parts, and 3 parts. Now we're going to shade in just like we did up here, 2/3 4 times. So I'm going to shade in 2. We're going to shade in 2. We're going to shade in 2. And we're going to shade in 2. So we shade in 1 2/3, 2 2/3, 3 2/3, 4 2/3, and we have 1 whole, 2 wholes, and how many parts? So we have 2 and 2/3. So that is the second strategy, is representing. Both of these strategies seem really good. Like, yeah, I totally know how to do repeated addition. That would be something that I can do. Or I can do this modeling. But I want you to think, what if our whole number was like 125? Do you really want to write 2/3 125 times and add it up? Do you really want to model 2/3 125 times? No. So there's always something that these both work, but there's something that we could do that might be a lot quicker, because I definitely don't want to stand here and add up 2/3 125 times. So that's going to be our next strategy. Okay, so our last strategy is going to be the algorithm, the procedure, just the math part of it without repeated addition or representing. So it's going to be the procedure on how to multiply a whole number by a fraction. Strategy 3. The procedure. So the first thing you do is you are going to multiply the numerator by the whole number. So our problem is 2/3 times 4. This means of 4. 2/3 of 4. We're going to multiply the numerator by the whole number. We multiply the numerator by the whole number, and then we're going to place it all over the denominator. So 2 times 4 is 8, and then we're going to drag the denominator all the way over. And then we need to convert or simplify. Well, we already did the math up there. 3 goes into 8 how many times? 2. 2 times 3 is 6. 8 minus 6 is 2/3. And the reason why we're multiplying the numerator times the whole number is because if we remember what we talked about, how numbers have a decimal at the end. They technically all have a little 1 exponent hanging over it. The same thing here, when we're talking about fractions and we're talking about whole numbers and fractions, we can think about our whole number. Use a different color so we can see it better. As being 4/1, right? We can think about 4 wholes being 4/1. It still represents 4 wholes. We don't write every whole number like this because we're not always using it in fractional form. But when we are, and we're multiplying a whole number times a fraction, we can place it all over 1. And when we multiply fractions, we multiply straight across. So we go 2 times 4, which is 8, and we would go 3 times 1, which is 3. Okay, so that is the procedure for multiplying a whole number times a fraction. You multiply the numerator times the whole number and place it all over the denominator, and then you convert it or simplify it, because we don't talk in 8/3, we talk in 2 and 2/3.